Okay, um, I'm looking at the YouTube comments. Is it live now? Green, it jumps between like 0 and then 2500 kbps or whatever. So that is the issue here. Um, am I audible right now? I don't think I might be audible. Um, okay. If I'm audible, please comment because okay. So I think yeah, I'm audible. Okay, fine. Yeah. So just we'll just hope that the stream goes nicely. Um, again, issues and network issues. Okay, so I'll start now. Okay, fine, yeah. So if you were and mostly I'll be going into some depth. Um, so okay, it is lagging definitely. Mm. Okay, so it is buffering on my side. I can see that. Okay, so let's start. Um, so the thing is that first let's this is the Rust website. So Rust is an amazing language that empowers everyone to build reliable and efficient software. So uh, why do you want to choose Rust? For performance, for reliability or productivity, something like that. I mean, you can see it in the web page. It's rustlang.org. Yeah, so that's mostly like so like without, and like if you want to install Rust, like if you are using Linux or Mac, then it's like just a one line thing. You can just copy this and paste it in the command line. You can install Rust. If you are using Windows, then you need to install an exe. So I mean, there's all the instructions are there clearly. So without further delaying, let's jump into okay. So let's jump into the let's jump into Hello World program. Um, just a second. Okay. Okay, so the thing is, okay, so let's go to something, hello world. So how do you, and then, so that's a main, function main, and then you can just normal println with the exclamation mark, and then just a normal hello world. That's it. So if I do that, yeah, so I get the output as hello world. So yeah, okay, so this is a normal hello world in Rust. Okay, so now let's go more deeper, like let's go into the styles of programming. So So if you are using Python or something, and if you want to find the sum of numbers till the nth number, maybe till like 10, so you will use a for loop, right? You will use something like s equals to 0, then I, and then print s, something like that, right? So this is imperative style. So what? So 0, then run a loop, I in range 10, and then s plus equals to I, something like that. You're telling the program what to do at each and every single step. In declarative, it's something different. Okay, it's like you're not telling the program how to do, telling the program what to do. Okay, so you have something like maybe like range 5. Okay, this was Python. This is some hypothetical program. I don't know if hypothetical language. I don't even know if it exists. So range 5 dot probably like something like iterate, and then like if I have already declared something like s equals to 0, so dot iter for each x s plus equals to x. Now you might think like both look the same because this is technically a loop. This is x, which is technically the I here, so it might seem okay, it is the same, but it is not. Like if you want to transform, for example, if I'm adding something like I have to multiply I equals to I, and here I can just add a map function, something like that, which maps every element 10 times. So map function is a function which applies another function over all the elements in the iterator. So if you have a range 5, then it just a sec. Okay, yeah, so if you have an iterator, it applies a function to all the elements of the iterator. The function is x into 10, and then it takes that x and it applies that for each function. So it's easy to do in this stuff. I mean, there's some getting used to it, but so these are the two different styles of coding, So people prefer declarative. React is declarative. React, that's the whole thing. Yeah, so luckily in Rust you can go both imperative or declarative. So you can just start typing something like let s mute s equals to 0, and then something like for I in 0 to 10, and then s plus equals to I, something like that, and then println okay s. Okay, so if I run it, it should run. Yeah, so 45, I'm getting 45. So the declarative way would be something like, I'll just remove the mute here, something like 0 to 10 dot, so that's already an iterator, so dot sum, because we have a sum function inbuilt if you want to just take the sum. So if I run that, then okay, so I have to give it as a type, so that will be use size. Yeah, so I'm just giving a type to s so that Rust knows what type s is. So yeah, 45 there. So both works. Okay, so Rust is a more strict language for types. So in the type sense, you have to specify types everywhere in the program. Not everywhere, it assumes a lot, but when it can't assume, then you have to provide the types. So okay, now let's try going to data types in Rust. So let's see the data types in Rust. So if you are new to Rust, if you have already used Python, Python has something like int, float, char, and I don't think char is there, str is there, bool is there, all those types are there, which is mostly everything. So that is Python. If you use C, there is there is short, all those, there's char and all those things, but if you come to Rust, there are a lot of types, obviously, and you have in C you have unsigned version of those, so unsigned version of those, so that is, it can't represent negative numbers, it can only represent positive numbers. So if you have unsigned int, it can only represent positive numbers. So in Rust you have U8, U16, U32, I16, I32, I64, and so you have something like first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, and the eighth bit. I'm taking an example of U8. So so you can store one something. So each bit can store either 0 or 1. So the total number of combinations of numbers which the total 8 bits can store should be 2 to the power 8, right? Because so because there are like okay, so there are like 8 bits, so that is there. Okay, so that is, I mean, this is integer types in Rust. If you look at float types, there is like F32, F64, 32-bit, and 6, and these are like the primary simple data types. Okay, this might be boring for some. I mean, I'm done with that, so I'll just strike this off. Okay, so that is data types in Rust, mostly done. Okay, so let's do something else. Let's leave all of this behind. Let's go to something like a higher level data structure, sort of. So you have structs. So structs are there in some languages. So if you are putting struct name, so you can put maybe like name equals to string. String is a type in Rust. It's an owned string type in Rust. So that is there. And when I'm declaring a structure, I have to declare the whole thing. Like I have to declare like maybe like 7 or something, So like you can declare a structure like that. So okay. Oh, sorry. Yeah. So you can declare a structure like that, and then these are warnings because I'm not using the name variable anywhere. So the Rust is telling me just remove the name variable from the thing. But yeah, output works. There is no error on the output. It's just warnings because I'm not using this variable anywhere. So yeah, this is simple as that. Like you can declare a structure. So in a structure, you have to declare all the fields. Okay, now you have enums. So if you're looking at enums, then enums, it's more powerful actually in Rust. So if you have something like enum type or something, I'm just putting some random name. So you can have something like integer, or you can have something like float, you can have something like str. So enums can be of a single type at once. Like I can put like type integer. So you can't use all the fields in an enum. Enum can only be restricted to one single field at a single time. So it's like if you know about this thing, the superposition principle in quantum mechanics. So like the cat can be dead or alive, the Schrodinger's cat. So similarly, an enum can have multiple states, but it can only be at a single state at a single time. You can't have multiple states in an enum. So what I do is I use a match statement. So a match, I can match upon a type, something like that. So I'm matching upon, okay, this is okay, yeah. So that was a keyword. Type is a keyword. I mean small type. Yeah. So I'm matching the type enum. So if it's a type integer, then I'm just printing something like success, or else yeah, that or I'll just put here, yeah, if it's not integer, if it's something else, like there are so many other types, right? There are float and string and bool. If it's something like that, then I'm printing fail, something like that. Okay, simple as that. So let's see if it works. Yeah. Okay, so yeah, it works. It's success because why? Because it's integer, right? If I'm replacing it by float or something, probably, then it should come fail. So say it failed. So that's how the this thing works. So enum is like the superposition state. So like there are like multiple states that can be only a single state a single time. And in a struct, all the states should be followed strictly. Like you should have value for all the states. You can't, just leave a state out just like that. You can't do that. So that is enum and structs. I'm just yeah. Okay. Yep. So that's done there. Okay. Yeah. Okay. So enums are done. Match. So this is match is just like switch in C. You can even use it as switch statement. Simple as that. You don't have to do a lot of stuff with that. So let's now go more deeper into languages and their features and stuff. Like how does a language, work? So if you're taking something like Python, okay, I'm writing again. If I'm typing something like print3 and then I'm taking something like s equals to 5 and then t equals to 8 and then print s, something like that. So how Python works is it just works as a normal human being. Okay, like we read line by line, right? Python also reads line by line. It is interpreted. So if you have something like print3, so it goes to print3 first. Okay, prints the 3 and then it goes to s equals to 5. So it declares a memory in s with the value 5 in the RAM, and then it goes to t equals to 8. So it declares a variable in the RAM t with the value 8, and then it prints 5. That's it. So in this program, if you look closely, you will see that we have never used the value t equals to 8, right? So that is a waste of performance right there. Like you have not used a value, but the interpreter, because Python is interpreted, it goes line by line. It has to declare the value in the RAM. So now you're just wasting memory there, and you're wasting that executing that particular line, right? So what if it's a compiled language? So people usually think that compilers are just like interpreters. They perform line by line things, but they do it before the execution of the code. Partially you're correct. I mean, you're completely correct. Compiler does the thing before the code, before the execution. It compiles every line into this thing, binary. But the most important thing is compilers can perform optimizations. So how do you optimize code? Now, for example, you have this code right here. Okay, I'm passing it to a hypothetical or a theoretical compiler, something like that. So yeah, so when the compiler looks at this code, it realizes that okay, you're not using the value t equals to 8. So it just removes the value before passing it to the compilation. Then it realizes you don't have to initialize s because you're printing it directly right away, right? You're not using it or you're not manipulating s in any other way. You're just printing it right away. So it removes s and it replaces it with 5. That's it. That's technically it. So the compiler removes all of these lines, makes all of those memory allocations and stuff. It removes all of it, and then it just displays in two simple lines, 3 and 5. What if you have something like, now you have 3 or 5. Okay, now let's remove this line. Okay, now you have like s equals to 5 and t equals to 8. Now you are writing a swap program, for example. So what you do is that you write something like temp equals to s, and then s equals to t, and then t equals to temp. So you swap there, and then you print s and t. Okay, for example, you have a code like this. Now when you use an interpreter, it will initialize s with 5, initialize t with 8, initialize temp with s, then s with t, t with temp, and all those stuff. It does it line by line, right? When you pass it to a compiler, what it does is that it realizes, okay, you're swapping the values here, right? So what it does is it goes on, deletes all of it, replaces t by 5 and s by 8. Simple as that. Okay, and then it realizes you're not even using it anywhere, so just remove the entire code and then directly print 8 and 5. I mean 8 and 5, whatever. So that's it. So that's the beauty of optimizations. You have, when you have optimized code, even if you're writing a long, statements without using anything or without, all of those things, everything just comes down to a single prospect and it's optimized. Optimization is a very important thing in computer science. Like, it has been there for the last 40 years, and this swap thing that I told you right now, it has been there since the last 40 years. So in the GCC. So let's go to Compiler Explorer. So I've already written one code here in Rust. So just some code. What it does is that it returns a usize. Now what usize is, it's an unsigned integer of the maximum. The size of the integer will be maximum for the given target system. Like mine is a 64-bit system, so it's 64-bit integer. So that is usize. So I've written a code here. Let mute s equals to 0 for I in 0 to 20, s plus equals to I, and then print s. So I'm just adding all those things to s, and then I'm returning s, okay, from the function. So you'll see a lot of code. This is the actual assembly code which generates. So like there is a lot of things like non-overlapping here. So it checks whether s is going out of bounds. Like there is like more value in s than it can hold. So it checks all of that. But if you compile it in release, just a sec. So if you compile it in release, look at this. It doesn't even initialize s, doesn't even goes to the for loop. It directly writes the answer in the binary. That is it. So like you have this 190, which is actually the answer after this for loop comes. Okay, and about the swap thing, we can see it now. So you have like something like swap, and then you return two usize variables. Just a sec, usize and okay. So yeah, so you have like let a equals to 7, let a equals to b, and then let b equals to temp, something like that. Okay, and then I'm returning a and b. Okay, I'm returning a and b. So look at this, right? Look right here. It is, if I go to, I'm just commenting this thing out so that I don't have to see the code for that. And I'm taking this, I'm removing this. So if I actually look at this, then yeah, even in the not compiled, even when compiling without any optimizations, it is directly returning the answer. It is not going to do this temp thing and all. It is not even going in these lines. Look at this. It's going in this line, and this line. Now if I apply optimizations, it directly gives the answer. Like look at this, 10 and 7. So you don't even have to go through a lot of time to execute or start preferring Rust. Or like, yeah, you can even prefer C and C++, but the thing is that those are unsafe languages. There's a new language in the town. It's known as Zig. So Zig is also a pretty good language, but the thing is that it's unsafe during the compile time. So if you have any memory errors, like maybe like free after, like double free, or maybe like giving a dangling pointer outside a function, nothing happens of that sort, right? Because Rust prevents it during the compile time itself. So you know that if your code compiles in Rust, it's safe and it runs fast, faster than all the languages out there, which so I mean, it's not a correct term, whatever. So yeah, that is there. Now let's go something into more interesting. Now people think that like C, C++ and stuff, it's more towards the core stuff, and or like Rust, it's more towards the core stuff. You can't make user applications with Rust. It's actually not true. You can make awesome things in Rust. You can make servers. There are like awesome libraries and all those stuff. So let me show you something. I don't know if it will work live. Let's try doing something. So if you have heard about WASM, it's a new standard currently. The thing is that JS has been there for the last 20 or more than 20 years. I don't know. So yeah, so the thing is that the thing is that you can't do a lot of stuff in JavaScript which is fast. Okay, uh, why? Because JavaScript is sort of an interpreted language. So now your machine, it receives JavaScript code from the web. Whenever you're opening a web page, it receives the JavaScript code. It has to go through it line by line. Okay, then it has to make that syntax tree, AST. Then it has to compile the functions which it's gonna use. And after compiling those functions in your local machine itself, and after compiling those functions, there's a watcher program. It keeps on watching all those functions. If some function is taking a long time to run, and now this is how everything is existing right now, because everything is literally JavaScript. Like if you have any desktop apps on Electron, it's JavaScript. If you have web pages, it's JavaScript. So there's a lot of there's a lot of area in that particular thing where you can optimize stuff. People don't realize it. So the thing is that, yeah, so now that's where WASM steps in. So what WASM is, you still need a virtual machine to run WASM, but it's optimized code. So it's more or less like Java bytecode or something, but it's much lighter than Java bytecode. Like you don't have threads and all. Like it's very light standard of portable code, and it's amazingly fast. So like you can write front-end apps in WASM fully without even interacting with JavaScript, and it runs amazing. It runs nicely. So and like if you even have an existing code base, you can port it to WASM and it runs on the web. Like I think Photoshop is now going to come to the web because of WASM. So let's try it out. Let's try something like PubFN, something like that. Let me just see. So yeah, something like, okay. Okay. Okay, actually the thing is that the output can't come. Let me just try if it's there in here. Okay, because this is rustc, this is a direct compiler, I'm not sure if I can do that. Okay, let's try something here. Let's go to WebAssembly Studio, if it's there. Yep, it's there. Yeah, so let's try that. Okay, just a sec. Normal hello world replace JavaScript. It is created to work along with JavaScript. Again, this is not that big of a deal. I'm just telling some things which are around the ecosystem and which usually exists. Yeah, so you have a HTML file which takes a JS file in the script. I'm just zooming it in and I'm just removing this. Okay, yeah, so okay, so yep. Okay, so main.js, and then main.js is this. Main.js calls WASM, and then you have your library here. Okay, so this is WASM. So it alerts a hello name or something. So if I just try to build this, okay, so what actually is happening here is it's calling the alert function from JavaScript, and it is passing hello and the name, whatever it's there, into this into the function as alert. So I'm calling here, okay, I'm calling a world right here. Okay, so if I just go to the output here, then let's see if it works. I mean, Oh, okay, run. Okay, yeah, hello world. Yeah. So like if I'm putting something else like uh, something like how are you or something like that, then um, yeah, see, so the thing is that you can interact with JS and you can make all those exciting apps. So this is normal simple code here. You can go to complex stuff. You can even, I mean, there are even libraries out there that will help you to write your entire web page and then run it in Wasm. So it's freaking fast and it's amazing also. So that is there. So this is all that I have to cover right here. I'm leaving this page. Like and if you want to continue doing Rust, of course, unlike other languages provide, by the way, and you have to learn a lot of basic computer science while doing this. Because you learn automatically because there's a lot of basic stuff involved while doing Rust, because Rust is a low level language, so which looks like high level. So I mean, yeah, so that's it. So that's pretty much it for the stream, I think. If you have any questions or something, you can just write, just comment there. I can answer it directly. I can show you some code if you want to, something like that. Or else I think that's it. I don't think I have any other extra topics to cover or something. Um, yeah, so if any questions or something, like, you can ask. Okay, so I think that will be it. Thank you for joining me, joining this stream. I mean, uh, hope you have a good day ahead. Thank you.